Hello everyone, I am Avani Saxena and I am pursuing Integrated MTech in IT from IIPS DLV. This video is a part of my assignment for the System Analysis and Design subject made under the guidance of Dr. Shaligram Prajapat sir. This presentation aims at understanding an expert system, its components, its characteristics, its development and their use in the current scenario. During this presentation, we'll be able to answer certain questions about an expert system, like what exactly is an expert system, why we use an expert system, what are its components and development stages, various softwares that can be used to build it, its applications, advantages, limitations, examples, etc. So first, we understand what exactly is an expert system. So an expert system is basically a logic and reasoning driven system that is used with artificial intelligence to stimulate a human's decision making skills based on certain data and knowledge about a particular domain that is pre-fed into the system. In simple terms, an expert system is a computer based system emulating the decision making ability of a human expert. Now, why we need an expert system is because it does not have emotions or a perishable memory like a human person. It is highly efficient and more secure, and it reduces the involvement of actual people, making it way more reliable. Which brings us to mention the certain common characteristics of an expert system, like it provides the highest level of expertise in any particular field. It reacts and gives result quicker compared to a human person. It is more reliable, error-free and flexible. That is, we can modify it to fit our requirements. It is comprehensive. That is, it is understandable by a user who may or may not be an expert in that field. It has a robust mechanism and it can handle complex problems. Now we see some common functional applications of an expert system in today's scenario. They are used for classifying different objects based on their characteristics. They are used to design particular systems based on certain specifications. They are used for process control and generation of various alternative solutions to any problem. They are widely used in the medical field to diagnose a disease or provide an appropriate medication for a disease. They are used for scheduling and planning and to monitor the behavior of a particular subject during scientific researches. An expert system requires various inputs and ideas like the development of a prototype, use of selected knowledge engineering to input the information into the system, use of problem solving tools to tackle various circumstances that may arise, and proper representation of knowledge and use of prototyping techniques. Now, some components of an expert system. The basic component of any expert system is the rule base, also known as the knowledge base. It contains facts and knowledge of a particular domain and various procedures to solve a problem. The user, who may or may not be an expert in that field, interacts with the rule base through an expert system shell that contains the interference engine and a natural language processor. The rule base in your system also incorporates other informations like a database, a graph base, and a model base. The interference engine fetches relevant knowledge from the rule base, interprets it, and finds a relevant solution to the user's problem. The interference engine uses two strategies for acquiring knowledge. The first is forward chaining. This process basically answers the question of what will happen next. It works by considering a few facts and using its decision-making logic to reach a particular conclusion or result, for example, during the predictions related to a stock market. And the second is backward chaining. This process answers the question of why a particular thing has happened. It is mostly used to find out the root cause or reason behind it, considering the circumstance that has already happened. For example, during the diagnosis of a disease through its known symptoms. Next, we see the development stages that are involved in building an expert system, which is basically comprises of 7 stages. The first stage is the identification phase, where we determine a problem definition and identify the problems that the system is expected to solve. Then we identify various resources that will be required to acquire the knowledge, to implement the system, and to test it. We also identify the goals that are to be fulfilled. The next stage is the conceptualization phase. Its main focus is to determine systems' key concepts and relations in order to build a conceptual base for the development of a prototype system. These concepts are built ensuring that all the general case scenarios of a problem domain are covered. The third stage is the formalization phase, which involves the mapping of all the key concepts and subproblems and determining the flow of information using various knowledge engineering techniques and various problem solving tools. Next is a system design phase in which the analyst or the designer specifies how the particular system will meet its requirements. The reports and the various outputs that the system must produce are identified. This stage is similar to the system design stage in any traditional system development life cycle. Next is the system development phase, which aims at the development of a prototype system. It includes writing of a code, its compilation, checking the logic, and designing the physical system. Next is one of the main stages, which is testing and evaluation phase. The prototype system developed in the previous stages is tested to check if it fulfilled its required goals. In the next stage, that is prototype revision phase, based on the result of the previous stage, we determine the issues and the conceptual changes that are to be made. The system is then accordingly redesigned and the data is reformalized. Next, we see the basic softwares that are involved in the development of an expert system. There are two main languages that have been used for creating expert systems for a long time, that are Lisp and Prolog. The Lisp stands for Lisp processing and it was designed for easy manipulation of data strings. And Prolog is a logic programming language which is used in artificial intelligence and computational linguistics. Over the years, these languages have been updated and improved, and many newer implementations have been created, like Common Lisp and Scheme for Lisp, and C Prolog, Turbo Prolog, and SWI Prolog for Prolog. These languages have also been replaced by other programming languages like C++, Python, Java, Haskell, etc. Some popular system building products and toolkits that are built from these languages include KEE, KMS for frame-based, and others for logic-based oriented, object-oriented, procedure-oriented, and rule-based languages. Comparison with recent languages. There is a small code snippet that compares the code to find factorial of a number n in Common Lisp and C++. Clearly, we can see that Lisp makes use of a lot more parentheses and notations compared to C++. On the other hand, we have Datalog, which is a subset of Prolog, compared with SQL as a rule-based language. The code represents creating of a new table / view or son of by performing a join on certain attributes of parent and male tables. As mentioned, the other alternatives include Python, Java, Haskell, and Clojure. Next, we understand the advantages of an expert system that include its high speed and robust mechanism, its efficiency to generate appropriate solutions, its low accessibility costs, and the ability to solve complex issues accurately, hence providing us a proper explanation with it. With numerous advantages, expert systems also have some limitations, like they cannot possess human capabilities. They might not always produce the exact result with the amount of knowledge provided. The data needs to be entered manually, hence requiring a lot of training and manual work. A particular expert system can only be designed to work for a particular domain, which also needs to be updated manually. Some widely used expert systems in today's industries include first R1 XCon for formulating a system based on certain specifications. CADET for identifying cancer, D-explain for medical diagnosis of various diseases, MYCIN for bacteria identification and drug recommendation, Dendrol for chemical analysis for researchers, PXDES to determine the degree of lung cancer, etc. Lastly, to conclude everything we learned in this presentation, an expert system is an artificial intelligence-based computer system that has the knowledge, decision-making, and problem-solving capabilities related to a particular domain like medicine or stock market. It has benefits like its high speeds, efficiency, and reliability, along with certain issues like its inability to incorporate human-like thinking skills and its maintenance. Commonly used languages for expert system development are Lisp and Prolog, although a number of new languages like Python are prominently used nowadays. I use certain books and articles to learn more about expert systems during the course of making this presentation, which are linked in the description. Lastly, thank you for watching the video. I hope it was helpful.